Hi guys, this is Marco with Students Teach Orgo. Today we're going to have another shorter video. We're going to go over the diazonium reactions. Now first things first, what the heck is diazonium? Diazonium is a kind of ion, particularly referring to this triply bonded nitrogen with this nitrogen having a positive formal charge. This is the diazonium ion. Now how do we get here? A couple of steps. So first we want to start with a benzene ring of some sort. Then we'll go ahead and nitrate it, adding this NO2 group, and then we can reduce this nitrate group, and that's usually done with palladium on carbon and hydrogen gas, but some other catalysts could be used as well. I think a common one that you guys might run into is tin, but it does the same thing, and that will reduce it to an amine. So you get this arylamine here. And then finally, we can react it with this NaNO2 in HCl, and then that will convert this amine to the diazonium here. And this is actually a very versatile molecule. We can do a lot of different kinds of reactions with it. So we're going to go into some of those now. The first one is the Sandmeyer reaction. That's basically taking the diazonium and then reacting it with this copper X compound. And X can be a lot of different things. Typically it's a halide like chlorine or bromine. Fluorine is also an option, I believe, or also some polyatomic ions like cyanide. So any of those can be X, and that will just replace the diazonium with the X. And this diazonium is a really good leaving group, so I'm sure you could probably tell. It's a triply bonded nitrogen, so if you just move the electron pair up, then it becomes nitrogen gas, and that's very stable, so it makes a good leaving group. Again, the product of this is usually an aryl halide or an aryl cyanide, whatever the X is. There are also more specific ways of making aryl halides for iodo or aryl iodides, I guess. We use Ki, potassium iodide. That will just replace the diazonium with an iodine instead. And if we want to make an aryl fluoride, then we just react the diazonium with HBF4, and that will replace the diazonium with F. These are specific to iodine and fluorine, so just keep that in mind when you're doing these. We can also make phenols this way, and there are two methods for this. The first one is using kind of similar to the Sandmeyer reaction. We're using copper and oxygen, so this copper oxide here. That will replace the N2 plus with an OH. Or if we don't want to do that method, we can also use just water and treat the solution with heat, and that will replace the diazonium with an alcohol as well. So two methods for this one. And then finally, if we want to go back to benzene from the diazonium for some reason, we can react it with this hypophosphorus acid here, and that will just remove the diazonium and give us back our benzene ring. Okay, so let's go into some practice problems. Go ahead, pause the video, and come back when you are ready. Okay, so for this one, there are kind of two methods to do it. I'm going to go over one method, but then I'll explain the second one afterward. So the method that I chose is first to chlorinate the benzene. So we'll do that by using Cl2 and AlCl3, and then that will add a chlorine. And now this chlorine atom here on the benzene ring, we know that this is an orthopara director, right? And so that's where the hint comes in, or the note, the pathways that give you a mixture of products are okay. Right, so we can end up with the next thing that we add either on either orthocarbon or on the carbon para to the chlorine. Now, just for the sake of the problem, we're going to select the para product, so we can go ahead and create the diazonium because we know that we need a fluorine at this position. We can get there using the diazonium ion. So we'll make the diazonium. We'll do our three steps. Again, those are nitration, reduction, and then the conversion to the diazonium, and then that will give us this intermediate. And then finally, if we want to add the fluorine, there are two methods to do this. We can use the Sandmeyer reaction way, where we use CuF, or We can do the other way using this HBF4. Either way, we're going to get the same product, and we're going to put a fluorine in this position and get our product. Now, you could have done this another way as well. You could have done the fluorination first, so you could have done basically all of this stuff first without the Cl, and then added the Cl last, because the fluorine is also an orthopara director, and it would give some of this product that way. But either method is fine. They give you the same thing. Okay, and problem 2. Okay, so for this one we have this this meta product here, and that should tell you that we're going to need some kind of meta director at some point. Now, we know that the OH is not a particularly strong meta director, and we know that the Cl is not a meta director at all. It's an orthopara director. So how do we get the meta product? Well, if we think back to the steps in the process of making the diazonium ion, I'll just go back on the previous slide to show, right? We know that this first step in that process is a nitration, and the NO2 group, that's a very, very strong meta director, right? So we can perform this first step of the nitration and then add the Cl or the OH or whatever, and then from there we can go ahead with the rest of the process to make the diazonium. So let's look at what that looks like. So again, we start with our benzene. Then we can nitrate the benzene and get this NO2 group. After that, right now we have our meta director, so we're going to react with Cl2 over AlCl3, and that will put a chlorine in either of the meta positions. And then from here, now we can go on and do the rest of the diazonium reaction. So we'll take this and do the next step, which is the reduction, and then finally the conversion to N2 plus with Na, NO2, and HCl. So that will give us our diazonium intermediate over here. And then lastly, again, if we want to make a phenol, there are 2 ways to do it. We can do either water and heat, so that will give us this product, or we can use the kind of Sandmeyer reaction-y way where we use copper oxide. But either way, we get the same product.